Let us try to solve all the problems given in exercise 3.2, and we'll also go through the concepts required to solve the problems when we do that. And please do not forget to like, share and subscribe the channel. So taking the first problem of exercise 3.2, given matrix A 2, 4, 3, 2 and matrix B being 1, 3, minus 2, 5 and matrix C being minus 2, 5, 3, 4. First, we need to find A plus B. Now, two matrices can be added if they are of the same order. So here, matrix A is of order 2 cross 2, B also is of order 2 cross 2. There are 2 rows and 2 columns. C also is of order 2 cross 2. So the individual elements can be added. Right? So A plus B is 2 plus 1 is 3, 4 plus 3 is 7, 3 minus 2 is 1, 2 plus 5 is 7. Next we need to find A minus B. So the corresponding elements are subtracted. So we have 2 minus 1 which is 1, 4 minus 3 is 1, 3 minus of minus 2 is 3 plus 2 which is 5. And 2 minus 5 is minus 3. Next, the third one, we need to find 3A minus C. Right? So what is 3A minus C? I need to multiply 3. So all the elements of matrix A gets multiplied with 3 and then we need to subtract it with the matrix C. So 3A is 3 into 2 is 6, 4 into 3 is 12, 3 into 3 is 9 and 2 into 3 is 6. Minus C is minus 2, 5, 3 and 4. So 6 minus of minus 2 is 8, 12 minus 5 is 7, 9 minus 3 is 6 and 6 minus 4 is 2. So we get 8, 7, 6, 2. So next 4, A into B. So when can we multiply two matrices? Now two matrices can be multiplied with each other only if the column of the first matrix and the row of the second matrix are the same. So here this is 2 and this is also 2. So we can multiply these two matrices. So how do we multiply? It is the first row elements with the first column elements. So the first row elements with the first column, that is 2 into 1 is 2 plus 4 into minus 2 which is minus 8. Right? So the elements of the first row is 2, 4. That is correspondingly multiplied with the elements of the first column which is 1 minus 2 and they are added. That becomes the first element here. Next, the elements of the first row with the second column, that is 2 into 3 is 6 plus 4 into 5 is 20. Next, the elements of the second row with the elements of the first column, 3 into 1 is 3 minus 4. So then I get 3 into 3 is 9 plus 10. So finally we get minus 6, 26, minus 1 and 19. Right? So next we need to multiply B into A. Right? So B into A. So let me write the matrix here. B is 1, 3, minus 2, 5 and A is 2, 4, 3 and 2. Right? So again the dimensions do match. The column of matrix 1 is equal to the row of matrix 2. The dimensions should match. So multiplying the first row with the first column, I get 1 into 2 is 2 plus 9. 1 into 4 is 4 plus 6. Then minus 4, that is the second row with the first column, minus 4 plus 15. And then I have minus 8 plus 10. So what do we get? We get 11, 10, and then we get 11 and 2. Right? So we have multiplied A and B, and we also have multiplied B into A, and we observe that A into B is not equal to B into A. Right? So A into B is not equal to B into A in matrix multiplication. Right? So we observe that these two matrices are not equal. Next, problem to compute the following. So first I need to add the two matrices. So matrix is AB minus BA, which has to be added with A minus B, B and A. Both the matrices are of the same order, right? So only if two matrices are of the same order we can add them. So the corresponding elements are added. So A plus A is 2A, B minus B is 0, minus B plus B is 0, A plus A is 2A. So we get 2A, 0, 0, 2A. So second one, we have matrix A square plus B square, next B square plus C square, and then we have A square plus C square, and then A square plus B square. So this is the first matrix, the elements of the first matrix. And the elements of the second matrix are 2AB, 2BC, minus 2AC, minus 2AB. So I need to add the corresponding elements. So when I add this plus this, I get A square plus B square plus 2AB. So what is A square plus B square plus 2AB? It can be written as A plus B the whole square. Right? When I add these two, I get B square plus C square plus 2BC. So that is nothing but B plus C the whole square. So I am skipping a step. So you can write one more step where these elements are added. This is A square plus C square minus 2AC. So this is A minus C the whole square. And this is A square plus B square minus 2AB. So we get A minus B the whole square. Right? Okay. So next we have the third one. So I have a matrix minus 1, 4, minus 6, 8, 5 and 16, 2, 8 and 5. So this matrix has to be added with another matrix 12, 7, 6, 8, 0, 5, 3, 2 and 4. So this is a matrix of order 3 cross 3. This also is a matrix of order 3 cross 3. So since we are performing addition, the corresponding elements are added. So minus 1 plus 12 is 11. 4 plus 7 is 11. Minus 6 plus 6 is 0. Next 8 plus 8 is 16. 5 plus 0 is 5. 16 plus 5 is 21. Next I have 2 plus 3 is 5, 8 plus 2 is 10 and 5 plus 4 is 9. So I have added two matrices of order 3 cross 3 and the resulting matrix is also of order 3 cross 3. Next, fourth one. So we have the first matrix, which is cos square x, sin square x, sin square x and cos square x. We are going to add it with another matrix, which is sin square x, cos square x, cos square x, sin square x. So when I add the corresponding elements, so this is a matrix of order 2 cross 2 and 2 cross 2. So when I add these two, I get cos square x plus sin square x. So we know that sin square x plus cos square x is equal to 1. So I get 1 here. So again sin square x plus cos square x is also 1. Add these two, I get sin square x plus cos square x is 1. And again cos square x plus sin square x is also 1. So I have a matrix here 2 cross 2 where all the elements are equal to 1. So next 3, So again I need to compute the following. The first one, I have a matrix AB minus BA, multiply it with another matrix A minus B, B and A. Right? So we can multiply two matrices only if the column of the first matrix and the row of the first matrix, the dimensions match. So since both the matrices of order 2 cross 2, I can multiply them. So how do we multiply? The first row gets multiplied with the first column, the elements of the first row then with the second column, and so on. So I have multiplying the first row elements with the first column, I have A into A, which is A square, plus B into B, B square. Next, first row, second column, A into minus B, which is minus AB, and then B into A, so plus AB. Next, the second row into first column, minus B into A, which is nothing but minus AB, and then plus A into B. Next, the second row into the second column, minus B into minus B, which is B square, and then plus A into A square. Right? So minus AB plus AB, they get cancelled, so I get A square plus B square, 0, 0, A square plus B square. So this is again a matrix of order 2 cross 2. So next, the second one. So we have a matrix 1, 2, 3 to be multiplied with another matrix 2, 3, 4. So please note the order of this matrix is, you have 3 rows and 1 column, so this is 3 cross 1, and this is 1 row and 3 columns, so it's 1 cross 3. So the dimensions of the column of the first matrix and the row of the first matrix, second matrix match, so therefore these two matrices can be multiplied. But what about the resultant? The order of the resultant matrix would be 3 cross 3. Right? So the inner dimensions here should match, but the dimensions of the resultant matrix would be 3 cross 3. So first row into first column is 2 into 1 is 2. Next element would be first row into second column, which is 1 into 3 is 3. Next 1 into 4 is 4. Next second row into first column is 2 into 2, which is 4. Second row, second column, 2 into 3 is 6. Second row, third column, 2 into 4 is 8. Next, third row into first column, 3 into 2 is 6. Third row, second column, 3 into 3 is 9. Third row, third column, 3 into 4 is 12. So we get the resultant matrix of order 3 cross 3. Right? So the third problem, multiply these two matrices. So this is of order 2 cross 2, but this matrix is of order 2 cross 3. So of course the column of the first matrix and the rows of second matrix do match. So these two matrices can be multiplied, but the resultant matrix will be of order 2 cross 3. Right? So let us multiply them. First row into first column. So I have 1 into 1, which is 1, plus minus 2 into 2, which is minus 4. Next, first row into second column, 1 into 2 is 2, minus 2 into 3, which is minus 6. Then again, first row into third column, 1 into 3 is 3, minus 2 into 1 is minus 2. Next, the second row into first column, 2 into 1 is 2, plus 3 into 2 is 6. Next, 2 into 2 is 4, plus 3 into 3 is 9. Next, second row into third column, 2 into 3 is 6, plus 3 into 1 is 3. So I am basically left with the answer, which is minus 3, minus 4, 1, and then I have 8, 13 and 9. So this is of order 2 cross 3. Right? So taking the next one, so I have two matrices, 2, 3, 4, 3, 4, 5 and 4, 5, 6. a matrix of order 3 cross 3, another matrix of order 3 cross 3, which is 1, minus 3, 5, 0, 2, 4, 3, 0, 5. So since both the matrices are of the same order, they can be multiplied, and the resultant matrix will also be of order 3 cross 3. So let's see what values we get. So first row into first column. 2 into 1 is 2, plus 3 into 0 is 0, plus 4 into 3 is 12. Next I have first row into second column. 2 into minus 3 is minus 6, 3 into 2 is 6, plus 4 into 0 is 0. Next, first row into third column. 2 into 5 is 10, 3 into 4 is 12, and 4 into 5 is 20. Next, second row into first column. 3 into 1 is 3, plus 4 into 0 is 0, plus 5 into 3 is 15. Next, second row into second column. 3 into minus 3 is minus 9. Next, 4 into 2 is 8, plus 0, 5 into 0 is 0. Next, I have 3 into 5 is 15, plus 4 into 4 is 16, plus 5 into 5 is 25. Next, I have 4 into 1, that is the third row into first column. 4 into 1 is 4, plus 5 into 0 is 0, plus 6 into 3 is 18. Next, third row into second column. 4 into minus 3 is minus 12, plus 5 into 2 is 10, plus 0. Next, third row into third column. 4 into 5 is 20, plus 5 into 4 is 20, plus 6 into 5 is 30. Right? So I need to add up all of them. So I get 14, 2 into 12 is 14, 0, and here I get 42. Next, 18 minus 1, so this is 56, right? So here I have 18 into 4, sorry 18 plus 4, which is 22, and then you have minus 2, and then I have 70. Okay, so finally we get a 3 cross 3 matrix when I multiply two 3 cross 3 matrices. So next, fifth one. So I have a matrix 2, 1, 3, 2, minus 1, 1. And then 1, 0, 1, minus 1, 2, 1. So this is a matrix of order 3 rows and 2 columns, but this is a matrix of order 2 rows and 3 columns, 2 cross 3. So the dimensions of the columns of first matrix and the row of the second matrix match. So the resultant matrix will be of order 3 cross 3. Right? So let us multiply this. So first row into first column. So we get 2 into 1 is 2, minus 1. Next I have 2 into 0, which is 0, plus 2. First row into third column. 2 into 1 is 2, plus 1. Next, second row into first column. 3 minus 2, 0 plus 4, 3 plus 2. Right? The third row into first column. Minus 1 into 1 is minus 1, minus 1. Next, 0 plus 2. Next, minus 1 plus 1. Okay? So we get 1, 2, 3, 1, 4, 5, minus 2, 2, 0. So this is a matrix of order 3 cross 3. So here we have a matrix of order 2 cross 3, and here we have another matrix of order 3 cross 2. So the columns of matrix 1 and the row of matrix 2 match, but the resultant matrix will be of order 2 cross 2. So first row into first column. So 3 into 2 is 6, minus 1 plus 9. Right? So next first row into second column. So I have minus 9 plus 0 plus 3. Right? Next second row into first column, that is minus 2 plus 0 plus 6. And then the second row into second column, minus 1 minus 3 is plus 3 plus 0 plus 2. So what do I get? So we get 14 minus 6, 4 and 5. Right? Okay, so problem 4. So given 3 matrices A, B, C, all of them are of order 3 cross 3. Okay, so we need to find A plus B and B minus C and verify A plus B minus C is equal to A plus B minus C. So we need to verify the associative law. Right? So let us write A plus B, or let me first write B minus C. So what is B minus C? Subtract these two. So 3 minus 4 is minus 1, minus 1 minus 1 is minus 2, 0. Then I have 4 minus 0 is 4, 2 minus 3 is minus 1, 3. Then I have 1, 2 and 0. Okay, so this is B minus C. So to this, let me add matrix A. So A plus B minus C. So when I add A plus B minus C, what do we get? So we get 1 minus 1 is 0, 0 minus 3, 5 plus 4 is 9, minus 1, 5, and then 1 plus 1 is 2, 1, 1. Right? So this is the LHS. So now let us find A plus B. I just need to add these two matrices. Right? So 1 plus 3 is 4, 2 minus 1 is 1, minus 3 plus 2 is minus 1. Next 5 plus 4 is 9, 2 and 7. And next I have 3, minus 1 and 4. So what am I doing? I am just adding the corresponding elements A plus B. So A plus B minus C. So let me do A plus B minus C, right? So this, the elements of A plus B minus C. So 4 minus 4 is 0, 1 minus 1 is 0, minus 1 minus 2 is minus 3, right? 9 minus 0 is 9, 2 minus 3 is minus 1, 7 minus 2 is 5. And then I have 3 minus 1 is 2, minus 1 plus 2 is 1, 4 minus 3 is 1. Right? So what we observe that A plus B minus C, this matrix and this matrix are one and the same and they are equal. Right? So we have proved the associative law. So given problem 5, we have two matrices A and B, both of order 3 cross 3. So we need to compute 3A minus 5B. Right? So what is 3A? I need to multiply all the elements of matrix A with 3. So when I do that, so what is 3A? So I multiply all the elements. So since I have 1 by 3, so 2 by 3 into 3 is 2. So I get 2, 3, 5. I am multiplying all the elements with 3. So wherever I have 3 in the denominator, it gets cancelled. So I get 1, 2, 4. And then 7. So here 2 into 3 is 6. And then 2. So similarly here, I need to multiply all the elements of B with 5. Because I need 5B. So whenever I have 5 in the denominator, it gets cancelled. So I get 2, 3, 5. So I have 2, 3, 5, and then 1, 2, 4, and then 7, 6, 2. So what do I need to do? We need to perform 3a minus 5b. Now observing all the elements of 3a and 5b, they both are one and the same. I find that all the elements are the same, isn't it? So 2 minus 2 is 0, 3 minus 3 is 0, 0, 0, 0, 0, 0, 0, 0. So I get a 0 matrix. So 3a minus 5b, we get a 0 matrix. So problem 6, we need to compute this. So I have cos theta into a 2 cross 2 matrix, sin theta into a 2 cross 2 matrix. So first let me multiply cos theta with this matrix. So we get cos square theta, cos theta, sin theta. And here I have cos minus sin theta, cos theta. And here I have again cos square theta plus. So here I am multiplying all the elements with sin theta. So I get sin square theta. Then sin theta into minus cos theta, that is minus sin theta cos theta. Then plus sin theta cos theta, and then I have sin square theta. So when I add these two matrices, I get sin square theta cos square plus cos square theta, and here I have sin theta cos theta minus sin theta cos theta, and here again I have minus sin theta cos theta plus sin theta cos theta, and here I have cos square theta plus sin square theta. Right? So what is sin square theta plus cos square theta? It is 1. So this is 1. These two get cancelled, and this is again 1. Right? So we get a 2 cross 2 matrix 1, 0, 0, 1, which is nothing but an identity matrix of order 2. Problem 7. Find x and y. So I need to find the values of x and y if 1. X plus y equals minus 1, 0, 2, 5, and x minus y equals 3, 0, 0, 3. So x plus y is a 2 cross 2 matrix. X minus y is also 2 cross 2 matrix. So we need to find the value of x and y. Right? So essentially x also would be a 2 cross 2 matrix, y also would be a 2 cross 2 matrix. So let me add these two. So when I add these two, I get x plus y plus x minus y, which gives me 2x. So what is 2x? Add the corresponding elements. So minus 1 plus 3 is 2, 0 plus 0 is 0, 2 plus 0 is 2, 5 plus 3 is 8. So this is 2x. To get x, I need to divide all the elements of this matrix by 2. So that gives me 1, 0, 1, 4. So this is x. Right? Next, to find 2y, let me subtract these two. So I get x plus y minus x minus y. Right? So that gives me x plus y minus x plus y, which is 2y. So when I subtract these two, I get 2y. So 1 minus 3 is minus 4, 0. 2 minus 0 is 0. 5 minus 3 is 2. So divide all the elements of this matrix by 2 to get y. So we get y equals minus 2, 0, 1 and 1. Okay, so this is y. So the next one, given 2x plus 3y equals 2, 3, 4, 0, and 3x plus 2y equals 2, minus 2, minus 1 and 5. So we need to find the value of x and y. So how do we do that? So first let us try to eliminate the value of x and find the value of y, and next let us try to eliminate the value of y and then try to find the value of x. So if I multiply this with 3 and this with 2, I get 6x and 6x here. So therefore when I subtract, x gets cancelled and I will be able to find the value of y. So multiplying this with 3, so I get 6x plus 9y. That means I need to multiply each and every element of this matrix with 3. So I get 6, 9, 12, 0. Multiply this with 2. So you get 6x plus 4y, which is 4 minus 2, 10. Right? So now what do? I subtract these two. So when I subtract these two, which is essentially 6x plus 9y minus 6x minus 4y, so I get 5y. So I get 6 minus 4, which is 2, 9 minus of minus 4, which is, so 6 minus 4 is 2, 9 minus of minus 4 is 13, 12 minus of minus 4 is 40, and then 0 minus 10 is minus 10. Okay, so therefore y is nothing but 2 by 5, 13 by 5, 14 by 5 and minus 2. So this is the value of y what we get. So next let's try to find the value of x. To find the value of x, I need to eliminate y. So let me multiply the first term with 2. So I get 4x plus 6y, which is 4, 6, 8, 0. So multiplying this with 2, and here I multiply this with 3. So we get 9x plus 6y, which is 6 minus 3 and 15. Right? So I need to multiply this with 2 and this I multiply it with 3. So to get the value of x, what we do is, so let me call this as 1 and let me call this as 2. So 1 minus 2, so I get 9x plus 6y minus 4x minus 6y. So we get 5x. So what is 5x? 1 minus 2. So 6 minus 4 is 2. Minus 6 minus 6 is minus 12. Minus 3 minus 8 is minus 11. And then I get 15. So x is 2 by 5 minus 12 by 5 minus 11 by 5 and 3. Okay. So this is what we get. Next, problem 8. Given y equal to 3, 2, 1, 4 and 2x plus y equals 1, 0, minus 3 and 2. Right? So we need to find the value of x. So how do we find the value of x? So if I subtract these two, I get 2x, isn't it? So 2x plus y matrix minus y will give me 2x itself. So this minus this. So 1 minus 3 is minus 2, 0 minus 2 is minus 2, minus 3 minus 1 is minus 4, and 2 minus 4 is minus 2. So what is x? Divide all the elements of this matrix by 2. So we get x equal to minus 1, minus 2 and minus 1. Okay. Next, 9. Find the value of x and y. So I have 2 into 130x plus y012, which is equal to 5, 6, 1 and 8. right? So here LHS equals RHS. So what does this mean? It means that 2 into 1, which is this, plus y is equal to 5, isn't it? So I essentially would get 2 into 1 is 2 plus y equals 5. Okay? And x plus 2 is equal to 8. So the corresponding elements added up here, LHS, is equal to the corresponding element in the RHS. So x plus, so here we have the corresponding element here, x plus 2 equal to 8. So 2 into x plus 2 equals 8. Okay, so what is y? Y is 5 minus 2, which is 3. And what is x? So here I have 2x is equal to 6, or x is equal to 3. So x is equal to 3 and y equals 3. So the next problem, we need to find the value of x, y, z and t. Right? So as usual, LHS equals RHS. So here I have 2 into x plus 3 into 1 must be equal to 9. So the corresponding elements have to be equal. So 2x is equal to 9 minus 3 is 6. So x equals 3. So we have got the value of x. So next, what about y? 2 into y plus 3 into 0 is 0 equals 3 into 4, 12. So y equals 6. So we have found out the value of y, which is 6. So next, what about z? 2 into z minus 3 into 1, which is minus 3, equals 15. So 2 into z equals 18. So z equals 9. So we get the value of z as 9. And next t, 2 into t plus 3 into 2, which is 6, is equal to 18. So 2 into t equals 12. So t equals 12 by 2, which is nothing but equal to 6. Right? So we have found out the values of x, y, z and t. Right? So from exercise 3.2 we have solved the problems from 1 to 10 in this video segment. So in the next video segment we will solve all the remaining problems from 11 onwards. So please make sure that you do like, subscribe and share the videos, and thank you for watching.